Hi everyone, I'm Pranoti, host of Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials or nanoscience, who tweets from the Real Scientists Nano Twitter account, which is realsci_nano. Hi everyone, my name is Pranoti. I am the host of Under the Microscope podcast, and today we have with us Kerstin Neuhaus, who is a group leader at the Forschungszentrum Jülich, which is in Germany. Kerstin is a group leader at the Institute of Energy and Climate Research, number 12. At the Helmholtz Institute in Münster, which is in the northwest of Germany and so towards Netherlands, something like that. So hi, Kerstin. Wonderful to have you on Real Scientist Nano or Under the Microscope podcast. How are you doing?
Hello, Pranoti. I'm doing fine. How are you?
I'm good. After recording the short podcast with you, I am really keen to learn more about you and more about your research. So let's start with what you mentioned in the short podcast, which is you started as a geologist. So how did you end up as a group leader now at the Forschungszentrum Münster? Tell us about your career, please.
Already when I was in school, I was really interested in volcanoes and in space travel, actually. So I really early decided that I wanted to be a researcher working on volcanoes. And to do this, in order to become a volcanologist, you have to study, for example, earth sciences. And so I decided to study earth sciences at University of Münster. And throughout my studies, I actually fell in love with microscopy because microscopy is really an integral part of earth sciences and mineralogy studies. So I started out with doing a lot of light microscopy and later on switched to SEM. And finally, during my PhD, I started working with AFM, which I'm still doing now.
Mm-hmm.
But during my studying geology, I really got in touch actually with a bit of space because I was doing my bachelor thesis on weathering of meteorites. But when you're working with meteorites, everybody is asking you, "Oh wow, meteorites! That's so great!" And then you say, "Yeah, it's really cool," and so on. And then everybody says, "Okay, and what can you do with it?" And because of this question, I decided that perhaps working in the area of material science would be a better idea, also because there are a lot more jobs than working on meteorites. And so I did my master thesis in Würzburg at the Fraunhofer Institute there, working on piezoelectric materials. And after this, I was searching for a job. And actually, during my studies, there were some courses on materials science at the chemistry department, which I listened to out of interest. And after some devastating replies to my applications, I asked the professor who gave the lectures, okay, Professor Wiemhofer, could you perhaps tell me where I could apply to get a PhD in material science, because I'm a geologist with major in mineralogy, and where could I do something having to do with material science? And about 30 minutes later, I got the reply, no, you don't have to apply, I take you. And that was the point where I started really working in material science. So I did a PhD in the group of Professor Wiemhofer at the University of Münster, again in the field of inorganic chemistry. And actually, when I came there, he showed me a more or less empty lab and told me, okay, I have lots of funding. I want a microscopy lab, but I don't have anybody who's working with microscopy. So this is your job now. Please fill this room and do some research. At that point of time, we were investigating oxygen permeation membranes and also lithium-ion conductive materials. And so, yeah, I was told to set up the microscopy lab, which I actually did. And this was also the reason why after my PhD, I really stayed for 7 more years in the same working group, because I never really did a PhD anywhere else, because all the people were coming to us to do the measurements. So I got into contact with a lot of different working groups, and I had more or less my own lab with a very good equipment where I could more or less do or not do what I wanted. So that was really, really a good opportunity to do research. So I stayed. And recently in 2020, I finally got the opportunity to become an independent group leader at Helmholtz Institute Münster. And more or less in parallel. So I started in the middle of the pandemic. I started at Helmholtz Institute Münster to set up my own group. And more or less in parallel, I got the opportunity to accompany the establishment of the International Graduate School for Battery Chemistry, short BACCARA, at the University of Münster for 18 months. So I was the person who was chosen to kickstart the whole project. And I did this until February of this year, and now I'm finally back to just doing research and finally setting up my own group. So this is, more or less my whole journey from geology to material science.
That is so cool. I'm so fascinated. And I'm also very glad that this professor was like, okay, you don't need to apply anywhere. I'm taking you. And it just fit right in your passion for microscopy or your fascination for microscopy. And then you were given or trusted with this opportunity to set up this entire lab. And of course, then a lot of people are coming to you, like a lot of researchers are coming to you because you have the microscopy expertise and the instruments. So that is so cool. And wow, this is so fascinating. It's amazing. It's amazing. So, Kerstin, you mentioned you started from as a geologist, and now you're a material scientist, a group leader actually in material science. And you also briefly mentioned your current research with AFM. And investigating different materials. What I want to understand is how does your current research fit in this big picture of materials and nanoscience? Because it's quite a broad field. So which piece of the puzzle is your research? Or yeah.
Yeah, well, I'm really working on real life electrolyte materials. So real life means this is not especially designed materials to do research with AFM. So this means we have mainly quite rough materials, because AFM, atomic force microscopy, normally means that you have very flat surface, very well prepared samples. Actually, we mainly don't have this. So we get the materials as they are received and have a look at it. And our idea, or the thing what we are doing, is that we want to have a look at interfaces in these materials, because they are super important for the charge transport throughout, either in the battery or in a fuel cell or whatever, because especially when you're looking, for example, at grain boundaries in a single phase material, they can either more or less completely inhibit the charge transport from one side of the electrolyte to the other side, or they can even accelerate charge transport in some cases. So these interfaces are really super, super important to get information about the material. And we are using a technique which is called Kelvin probe force microscopy. So with this technique, you are measuring the surface potential at different areas. So you can map this in combination with the topography of your sample. And in case of ceramic samples, you can very clearly see if you've got a grain or a grain boundary when you are looking at the topography. And then you can more or less zoom in on the grain boundaries and see the surface potential differences there, which tells you something about, is charge transport going very well there or is inhibited there. And in case of composite materials, you can also have a look. You can address individual areas of your composite. So you can have a look at the single constituents and of the interfaces of these constituents, which are also similar to the grain boundaries, either inhibiting or improving the charge transport in your material. And this is what I'm focusing on. So my task is mainly adapting and improving the method for special materials which we are having at the institute.
Okay. That's really cool. It's really fascinating, actually. And you mentioned that you're working with electrolyte or like battery materials. So are you working with materials that we can use for hybrid cars or electric cars?
Yeah.
Or is that like something different or?
No. That's exactly what these materials are intended for. So the electrolyte is an integral part of your battery. So you've got an anode on one side and a cathode on the other side, and in between there is the electrolyte, which has the role to transport mainly lithium ions, but also other ions, depending on which type of battery you are using, from the anode to the cathode or back, depending on whether you are charging or discharging.
Mhm.
And yeah, I'm looking into these electrolyte materials, and I am mainly working on actually on fuel cell materials. So they are not mainly used for electric vehicles, but my colleagues are also developing electrolytes for lithium ion batteries or lithium metal batteries or whatever, and these can actually be applied in your car, so or in your power tool, in your laptop, whatever. This is really
Wow.
important.
Wow. Oh yeah, we need that. Can we just like pump a lot of money in your research and get that happening? Because electric cars, I feel in Germany, we are not there yet. We could be a bit faster. Uh,
Yeah, but I think there is already there has been done a lot. I mean, obviously, we are still happy if we get funding. I don't know any scientist who isn't happy about funding, but I think there has been done a lot, especially at our institute in Münster and the surrounding institute, because Münster has in the last few years become a hotspot of battery research. So this is really yeah, also a point I will probably be a bit talking about in the Twitter week.
please do. So, Kerstin, I think your research is super fascinating, and I feel that in these lot of years of experience that you've had and working with several different kinds of researchers on different materials, and also from your geology days. That you're involved or you were involved in a lot of interesting research projects. And this is a mean question, to say the least, which I want to ask you. And that is, if you have to pick one research project that you're most proud of, or the most fun or quirky one, could you pick one research project and explain it to us in super simple words in the section we call In Other Words?
May I pick two? Because
Okay, fine.
okay, because actually I'm still very proud of my bachelor thesis. Although this has been quite a while ago, but I got the opportunity to study the weathering behavior on actual meteorite samples. So we had small like cubes cut from the meteorite El Hamami, and then these were stored under different conditions on different soils, and I was monitoring the weathering of these small samples in order to get information when you find a meteorite. Yeah, what information can you get? How long it already has been on the ground, and what is the effect if it's on, I don't know, on sand versus the effect if it's on something like yeah, in the rainforest there on the ground. And that was really, really great, because working with material from space is just cool.
Which is really
I
cool.
really loved it.
Kerstin, you mentioned the name Al Hamami. Can you tell us? Because I don't know what that means. Does that have a
Uh,
meaning or like which
ac-
meteorite is it from Mars?
no, it's not from Mars. A stone, so-called chondrite. So it's a meteorite, not mainly meteorites are made from metals, more or less, but there is some parts of the meteorite are not made from metals, and they can be so-called chondrites. Chondrites are meteorites which have small, spherical features when you look at the microstructure of these meteorites, which are called chondrules. And this meteorite is not from Mars, but meteorites get their name from the nearest post office where they are found, actually. So it was found near the town of El Hamami in Africa. So and it's called El Hamami. So it was located there, and it's not the name is not from the location where it came from in space, but the location where it was found on
Wait,
Earth.
okay, sorry for interrupting you,
Yeah,
but
no problem at all.
I understand this as well. I did not know that. Okay, please go on. So, okay, that was your bachelor work.
Yeah, I'm still really fascinated by geology and space and all those space travel things and so on. So
Mhm.
this is really one. I'm very fond of it.
Yeah.
And the second project, which has more to do with my current research, is something that I actually started even already in my PhD, but I'm still using now. So I developed a method to measure chemical diffusion coefficients in a material by taking the AFM tip to the material, putting a voltage on the material, and afterwards monitoring the surface potential with this Kelvin probe force microscopy method.
Mhm.
And when you polarize a conductive sample, so electrolyte materials are obviously ionically conductive somehow. When you polarize it, you either push away ions or you attract the ions, and then you can, when you stop polarizing and have a look at the surface potential, you can see how everything is going back to its initial state. And
Mhm.
so it's somehow diffusing in the material, and you can take this information to measure the local diffusion coefficient. And I was applying this to the oxygen ion conductive materials, and these materials normally work at really high temperatures, so something like 800 degrees C. They are completely fine with that, but at room temperature they are used for some special applications, but normally you can't measure the diffusion coefficient because there is only some surface charge transport left, and the whole bulk is just not working at these low temperatures like room temperature. So I was really happy that I could use the AFM to still measure something, and also to get consistent information about diffusion coefficient. And this started already during my PhD, and I was making the method better with every year. And it really got traction in a cooperation with the Max Planck Institute in Stuttgart. I think 3 years or 4 years ago now. And I'm really happy about this process, about the development process, and that it turned out so fine. So actually, my PhD student just won a poster prize for presenting on this method. So I'm still really proud that this is working out so fine.
That sounds really cool. I can understand why you picked two projects. I mean, the first one is a no-brainer for me. Like, if I had done that research, I would always pick that as my one of my favorite projects, definitely. And also your second research project that you spoke about. And you also mentioned that you worked with someone at the Max Planck in Stuttgart. So that's where I spent 3 years of my life during my master time. Uh,
Okay.
so who did you work with, if I may ask?
Um, I was working with Professor Meyer and
Ah,
Giuliano Gregori, who was group leader at that time.
uh-huh.
I think he's now located somewhere in Munich, and he's not in academia anymore. But
Okay.
it was a really, really nice cooperation.
Okay. Yeah, Professor Meyer. Yeah, that one I know. Just to find some commonalities. The world is so small. Um, so it's clear to me, Kirsten, after speaking with you for almost an hour now, that you really enjoy the research aspect of being a scientist. But what else do you enjoy about being a scientist?
Well, I really love that it never gets boring. So I have the equipment, and all the people are coming, and they want to measure something, and I have to find a way to help them. And so new things are literally just around the corner. Go to the next lab and ask the colleagues what they are doing, and they are working on something completely different than you are, and yeah, get some new ideas, get a new perspective. So this is yeah, I really love to engage and network with them and get new ideas. So this is yeah, I think I will never be bored by science. So that's what I like about it most.
That is amazing. That's really cool. I'm so happy to hear that. And you're right. Yeah, there is always something new around the corner and unexpected ways, and sometimes hopefully expected ways as well, because well, we do want to get results that we expect to get. Kerstin, it sounds to me that your research experience has been wonderful so far, and I hope it will continue to be wonderful in the future as well. But if you had three wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
Yeah, I think the first thing, which probably is not so far away, is that I want to have the regular in-person coffee breaks back, because that's the point where you have really good discussions, where you meet people, where you engage, where you sometimes get really good new ideas. And yeah, I really love coffee, but apart from that, that would be a really nice thing, because at the moment we should work from home as often as possible, and so I haven't met most of my colleagues actually, because I started at the Helmholtz Institute during the pandemic. So I think 80% of my colleagues I didn't meet in person so far. So
Wow. Okay, so in-person coffee breaks. Okay, done.
yeah.
What next?
I think the next thing is also a point which most scientists can relate to, so easier access to funding, because writing all those proposals really takes a lot of time.
Yeah.
And yeah, it's yeah, sometimes really tedious process. So if you could just be eligible for funding every, I don't know, 3 years, you get a small amount of money from your institute or whatever, that would be great. So
Yeah, regular funding without having to worry about writing proposals and rejections and the process.
yeah, at least for a small, I don't know, one PhD student or something like this, so you can continue with your research, and that for every group leader, that would be great. But yeah, I don't think this will come up anytime soon. So
No, no,
yeah,
no, no. But I would like to believe that we are working towards it. I mean, if we have scientists like yourself who are aware of this, and you are in a position, or you're getting even more in a position to make a difference and have make a difference, that's yeah, the future. Hopefully, in near future, we will at least start working towards it.
yeah, that would be really great, especially at the universities. They really have a problem balancing between teaching and doing research, and you can't do everything equally good. So
No, definitely not. Definitely not. But very realistic wishes so far. The first two. What's your third one? The last one.
I think the third one also is realistic. So I really would love to have more physical space in the lab, because we don't have our own building. So we are sharing some rooms with the university, and we also rented some rooms at a research space, but we don't have an own building, and we really don't have much room to put any instruments or to really work. I'm already quite well off, because I've got my own office at the institute, but yeah, the labs are really cramped and crowded. So I really hope, I think in 2024 we will get our own building, and then hopefully this problem also gets solved.
That is amazing. Wow. All three wishes, very, very realistic wishes, and I hope they all come true soon. I think the first one is the most realistic one that will become reality soon, the in-person coffee breaks.
Yeah, I
Uh,
hope so.
Yeah, that would be really good. So, Kerstin, I really enjoyed our conversation. I learned a lot from you about geology, about material science, about you, about Münster. I feel that I want to keep talking to you for hours and hours and ask you all kinds of questions. But
Thank
I
you.
do have to let you go at some point. But before I let you go, I have one last question. And I can't let you go without understanding or learning more about your learnings from the pandemic that we are living in, which started over 2 years ago now, and I hope it will stop at some point. But yeah, could you please share your learnings from the pandemic?
Yeah, sure. I must say that I'm really grateful for the many opportunities to work from home because, yeah, the increased flexibility is really good. Also, I have little kids, so when they are sick or something like this, it's really good that you have the opportunity to say, okay, I can at least do some things from home. And also, like conferences and so on are now either virtual or hybrid oftentimes, so you can still join and don't have to travel all the time. Although I like traveling, but with small kids, it's still another thing than when you're just yeah, single and go around for yourselves. Um, Also, I like that there are a lot more coast-free talks, so you can just yeah, there are so many opportunities to listen to research from other colleagues. But yeah, on the other hand, like you already hear, I really miss the coffee breaks. So this is really a bad point of the pandemic. And yeah, I think the overall interaction with colleagues has really got to a minimum because you're making a Zoom call or something like this, and yeah, then when it's over, it's just over. There's no possibility to just chat a bit, and this is really sad. So I think we have to establish that again to yeah, to get going again, to improve research, to improve our output, to get new ideas. This is missing at the moment, I think.
Yeah, definitely, definitely. Yes. So thank you very much again, Kerstin. Really looking forward to your time on Real Scientist Nano. I hope you enjoyed the conversation as well. And yes, just thank you again.
Yeah, thank you so much. I'm really looking forward to twittering on Real Science Nano, and yeah, thanks for having me.
Listening. This is Pranoti, host of Under the Microscope. To know more about us, visit our website, thesciencetalk.com, and follow us on Twitter at realsci_nano.